Alright, we're going to work on the 4 practice problems on page 414. These are in the standard wave descriptions. So here in the first one we have, we're talking about having 8 waves. So there's 2, 3, etc. We're going to have 8 waves, and that's going to be 60 meters long. So we're looking for the length of one wave. So 60 meters per 8 waves will give us the length of one wave. We have 7.5 meters per wave. That would be the length of one. Alright, looking at these same waves, if they move 3 meters per second, we want to know what their frequency is, which should tell us about how often the waves hit the beach. So we have this wave moving. It has a wavelength lambda. It moves at a speed v, and I want to know what the frequency is. And the v equals lambda f is what's going to relate them. So we know the wave speed is 3 meters per second, and we know from above that the wavelength is 7.5 meters per wave. So the frequency is 3 meters per second divided by 7.5 meters per wave, which will give me 0.4 waves per second, which is 0.4 hertz. So they don't hit the beach very often. If I take the inverse of that, I get 2.5. So it's about 2.5 seconds between waves crashing, which is about right. Okay, new situation. Now we're floating on a raft in a wave pool, and she noticed that every 3.5 seconds she moves down and then back up. So that would be a full cycle of that wave, and she bobs between 4.5 and 6.7 meters. So there's a 4.5 meter mark there, and a 6.7 meter mark there, and so we're saying from the bottom of the wave to the top is that much, which these are full waves here, not just wave pulses. So our amplitude is going to be that whole distance divided by 2. The equilibrium level of the water would be here. Anytime there's a wave that goes up, there has to be also a corresponding dip. Otherwise, we would have more water than we started with. So the difference is 2.2 meters, which means 1.1 meter is what we get. We divide by 2. That would be the amplitude of these waves. Those are pretty big waves. So this is like a a wave, those cool wave pools that's on a pretty high setting. The frequency of these waves, we're saying that for her to go from up to down and back up happens in a delta t of 3.5 seconds. That's one wave because she's gone from the peak of one to the peak of the next one. So the frequency is one wave per 3.5 seconds, which will give us a frequency of 0.286 hertz. And telling us that these waves, as they go, have a speed of 7 meters per second. We already know from above that they have a frequency of 0.286 hertz. And we want to know at this point how far apart 2 crests are and 2 troughs. So what that is, if I just draw that out here, this is the distance between 2 crests, and this is the difference between 2 troughs. That's the wavelength. So we're trying to figure out what the wavelength is. And once again, v equals lambda f. V is 7 meters per second. Lambda is unknown, and the frequency is 0.286 hertz. So lambda equals 7 meters per second divided by 0.286 waves per second, which will give us a wavelength of 24.5 meters per wave. You can check that unit cancellation, make sure it works out. And if the frequency of these waves were doubled, so if they arrived twice as quickly, there's half as much time in between, what would the wave speed be? What would the wavelength be? What would the amplitude be? The wave speed would be the same because I haven't changed the medium. I haven't changed the water. In particular, the depth of the water is usually what it's about. But I haven't changed the medium. All I've changed is the waves, and that does not change the wave speed. So what would the new wavelength be? Well, v equals lambda f is still true. The speed is 7 meters per second still, and if I double the frequency of these waves, so that would make it 0.572 hertz. My new lambda I can calculate would be 12.24 hertz, or 12.24 meters, and that's half, right? So if I double one, I halve the other. You can make a conceptual argument there as well. If you don't want to calculate it, or you might not have that initial number to be able to calculate it with. But if you double the frequency, you're going to have the wavelength, and if you double the wavelength, you're going to have the frequency. So we know the wave speed would be the same. The wavelength would be 12.24 meters. They're a little different because of rounding. And the amplitude, we don't know. Amplitude is independent of all these things, or all these things are independent of amplitude. So it depends on how you create the waves as to what the amplitude would be.